Conservation of momentum. So in this video we're going to focus on the concept of conservation of momentum. So due to Newton's second law, if there are no forces acting on a system, then there can be no change in momentum. So that means the total momentum of the whole system doesn't change. Another way to say this is that the initial momentum of the system is equal to the final momentum of the system, provided there's no external forces. So writing it with an equation, the final momentum is equal to the initial momentum, keeping in mind that momentum is a vector quantity. And rearranging this equation, you can see that the final take initial is 0, meaning there is no change in momentum. Observing the animations on this slide, there are two types of collisions that can occur. The first is elastic, where the two particles bounce off each other. And the other type is an inelastic collision, where the particles attach and form one mass. Alright, seems to be a lot going on in this slide. However, what I'd like you to have a look at is the terms in this first equation here. So with an elastic collision, we've got one particle's momentum here, one particle's momentum here, and when they bounce off each other, that first particle has this momentum with a different velocity, and the second particle has this momentum with a different velocity. Okay? Compare that to the inelastic collision, where on the right hand side, after collision, the two particles join, and since they're joined, there's only one velocity. Alright, this question should be a bit challenging. What I'd like you to investigate is kinetic energy conserved in an inelastic collision. Okay, so this is one where particles stick together. Start with a couple of simple one-dimensional examples and see if you can determine the answer. And don't forget, the kinetic energy of a particle is half mv squared.